Saxon's Trig, Lesson 16, beginning on page 122, is about complex fractions, abstract equations, and division of polynomials. In Part A, complex fractions, complex is obviously giving you the idea that this is something that is not simple in form. It's got a lot of parts to it. So let's jump to example 1 and we'll work our way through what this means. And I will tell you now, every year students hate these problems because they are all in letters and they're wanting you to use your algebra rules to solve. This is complicated. It is complex. So a complex fraction is basically a whole bunch of fractions stuck together. So the students don't like them because you have to continue to use the algebra rules. However, they are the same rules over and over and over. Once you know them, working through the problem should not be bad. I will give you this clue. You don't want to start at the top. You want to start where the most complex things look, in the bottom of this problem. And so break it down piece by piece. So I'm going to ignore all of the top and just deal with this bottom part. And if this is all I had, what would I need to do in order to add those? Fractions need common denominators to be added. So that means the common denominator should be a d. If I put a d in the denominator of this fraction, I need to keep it balanced by putting a d in this one. So now we're going to rewrite everything that we had that we have not used yet, m over, and this is ready to do a combined fraction. So it's db plus c over the common denominator d. Okay, so now again, since I'm working from the bottom up, these parts are not needed yet. This is a fraction over top of another fraction. So just so you can see that m is in a fraction form, that's m over 1 being divided by another fraction. Fractions mean division. When you divide fractions, you really multiply and flip the lower one. So this one flips as it moves up and becomes d over db plus c. And we're going to multiply those two together. Again, I'm going to write what I have not used yet, and now I want to do the combination here. So this gives me md over db plus c. Now I don't need the top. I need to work with just this fraction. So again, to add fractions, I need a common denominator, which would be db plus c. db plus c. And what I put on the bottom, I need to make sure I am adding to the top to keep it balanced. So this whole unit needs to distribute with this a. X over top of, I haven't used that part yet. And let's go ahead and do this distribute. A times db. And again, remember a also has to multiply with the c. And we still have the plus md, and they all have now the same denominator of db plus c. Okay, so you see why students don't like it, because it's complicated. It's easy to make a mistake, but I'm still doing the same steps. Common denominator and division of fractions means flip and multiply. So here now we're ready to use the x. This implies x over 1 as its fraction. This one is dividing underneath it, so we're going to move it by flip and multiply. So this turns it into db plus c over everything I had here, a db plus ac plus md. And then our final part is to do x distributing with, so x db plus xc. And my common denominator multiplied by a 1, so there's no change with the ADB plus AC plus MD. Now I do stop and check to make sure that I don't, and I shouldn't have something that's in all of them, but I stop and check just to make sure there's no simplification. These both have an X, but these down here don't. This doesn't have a D, so I don't see anything where I've got the same letter in all of the parts. So that is the final answer. Now in the book, they left it with the X and a parenthesis with this dB plus C, and they didn't do the distribute. I tend to prefer the answers distributed out. They did the same thing with leaving something down here in a parenthesis. I just feel that this is a little bit easier, but you can do the answer in whatever way, it's fine. Example 2 gives us a over x squared plus b over x all over top of m over x squared plus k over xc. Again, I want to follow those same algebra rules, which say that when I go to add these two fractions together, I need a common denominator. That should be x squared. It's the larger of the exponents. So to make this one x squared, it gets another x, which means I need to put an x on the top to keep it in balance. I can go ahead and combine those, or I can move down to the common denominator here. It doesn't matter which order you're doing things in. So if I just write this as one fraction, that's the numerator simplified as far as I can go. Then the denominator down here, common denominator, needs to be x squared c. So this one needs the c. Keep it balanced by adding the c. This one has the c, but it only has one x. So to turn it into x squared, I'm adding another x. Put one in the numerator to keep it balanced. Now combining mc plus kx all over common denominator of x squared c. Now we're down to fraction over fraction. So this is the bottom one. It's going to flip and multiply. So that's turning this into x squared c over mc plus kx. Now before I do this multiply, I look to see, can I make my life simple by canceling something out? Yes, I have an x squared in the denominator and in the numerator, so they kill each other off. Remember that you cannot change, separate, reduce, cancel, however you wish to state it. This is a unit stuck with a plus sign. This is a unit stuck with a plus sign. You cannot change those. These were multiplying, so they can be separated, not a problem. Since I don't have an extra c, and I can't cancel with this one because it's part of a unit, I'm going to just distribute c with this numerator. So ac plus bxc. Is there a rhyme or reason in the order of the letters I'm writing? No, it's however I wish to choose to do them. Some people try to put them in alphabetical order, not critical. And then this no longer exists, so the only thing I have for the denominator are those parts. I do a quick check just to make sure I don't have anything shared in everybody. They all have C's except for this one. And since it doesn't have one, it can't be fixed. Just making sure I match the answer key. Answer yes. Okay. Part B is abstract equations. Now, it's the same as what we were just doing, except an equation tells me that I have an equal sign. So we are being given y equals v multiplying with a over x plus b over mc, close out that parenthesis. And because this is all letters, I have no idea what I'm supposed to do unless the problem tells me. And when I look, it says, solve for c. So this c is ultimately what I want to get alone all by itself, so that the problem says c equals, and obviously it'll be a mess of letters, but that's ultimately where we're going. Again, you have multiple ways you can do this problem. I usually start with distributing this out into the parenthesis. So y equals, and this implies v over 1. So the v is multiplying with the numerator only, and then it is multiplying with the other one. So that gives me vb, and the 1 wasn't changing this denominator, and it isn't changing this denominator. And again, I know I'm solving for the c. Now I have fractions that can be combined together, and the common denominator will be xmc. Y equals, and the common denominator xmc. This has the x but does not have the mc, so we want to put the mc with that numerator. This has the MC but doesn't have the x, so we need an x with this numerator. So now I'm gonna just combine all of that, VAMC plus VBX. Now that I've gotten it here, I know I need to remove this fraction, and I realize I've now added a c in the numerator, but that's okay. We're going to fix that here in a minute. I need to get rid of this as a fraction. So the denominator needs to multiply to the other side. So that will give us yxmc equals VAMC plus VBX. Now, I did say that there were other ways to think your way through this. At some point up in here, I could have said, I know that I want to get rid of all of the denominators because it's an equation. So I'm going to choose to multiply this entire problem by xmc, the common denominator. And that would have multiplied y with, because it doesn't have anything, the implied 1 in its denominator, needs all of the parts of it. So that would give me y xmc, matching what I got to here. This one has the x, needs the m and c, just as we did from before, taking you straight to this. This has the MC, needs the X, as we did here, taking you straight to this. And so you can bypass writing it as a full fraction if you choose to multiply by the common denominator at this step. Either way you do it, you're getting to the same place here. And again, we are solving for the C's, so I need any part with the C to come to one side of the problem. We're going to move this part with this C over here to join. YXMC minus, because I'm changing its sign in front when I move it, equals VBX. Whatever, this was not moved, it just drops down. Now I factor out the C, and what is left when I pull C out? YXM minus VAM, and I pulled the C out, equals VBX. And the final step to get C all by itself is to remove this parenthesis from with it, which is multiplying, so we're going to divide it. That means putting it underneath this one. So VBX is the numerator, and YXM minus VAM is the denominator. Again, I do a quick check to make sure that I don't have any pieces that can be reduced out, but I don't, so there is the fractional answer. Last one, section C, is division of polynomials. Be grateful that you only have to do this very long division, which you should have done a lot of in Algebra 2, just a few times in the Trig book before they give you a shortcut so that you don't have to do this long thing ever again. But for now, here is how we do the long division. It says in example 4 that x cubed minus 2 needs to be divided by x minus 1. Now that's what they've given me. It says check your results. Yeah, I typically don't go through the checking step, although it's asking you to. So here are the division steps that we're going to do. I realized when I wrote my original that this was not in the correct format for this to work. To be in the correct format, I need to have everything in descending order and an exponent for every single piece. So it begins with x cubed. I need an x squared, a plain x, and a no x term. Here's my no x term. So I do not have, it is implied, and I need to write an x squared term, but one doesn't exist. So I write it as a 0x squared and a 0 plain x, and then the minus 2. This is dividing by the x minus 1. Okay, here we go with these steps. Compare first piece with first piece. This is a single x. It's supposed to be an x cubed. How many more x's do you need? 2 more. But don't write that above the x cubed because you're dividing by a 2-piece thing. It's actually going to line up underneath the second one. So you're going to put the x squared that you need to turn this into x cubed here. So once you compare first term with first term, write what you need. The second step is to multiply this with every part here. Distribute. X squared times x is x cubed. X squared times -1 is negative x squared, or -1x squared, either way. Third step, always multiply what you just distributed. Your goal here is that these first two should be identical and cancel off. X cubed minus x cubed is gone. 0 minus a negative. Ooh, minus a negative means positive. So 0 plus x squared is just x squared. And in all division that you learned back in elementary school, after you finish that step, you drop the next piece, which gives you the 0x part. Now, repeat those steps all over again. Compare first part to first part. What does x need to become x squared? It needs another x. It's going to be positive because there's no negative signs that I'm dealing with here. So now distribute. X times x, x squared. X times -1, -1x. Always subtract that entire unit. X squared minus x squared cancels off. 0 minus a negative, again, that's a plus. 0 plus 1 is x. And drop the next piece, -2. Compare x to x. Ooh, it has what it needs. So I need a 1 implied for the multiply because I don't want to make a change. 1 times x, x. 1 times -1, -1, subtract the entire concept, x minus x cancels off, -2 minus a negative, that's plus, -2 plus 1 is -1. I don't have another piece, so I know I'm finished, and that means that my -1 is my remainder. So I write, now you could say plus -1 in the numerator, but typically whatever this sign is the sign that gets written here, and then we just write 1 as the leftover, and the denominator is whatever you were dividing by, x minus 1. Now they don't do another example of this. They trust that you have it based on that, and again, be thankful that you only have to do a few of these before we get a shortcut version. But this is the answer and its remainder.